Hello everyone, welcome back to my channel Code with AKJ. Today is day 28 of solving GeeksforGeeks problem of the day. Today's question is middle of a linked list. So the question says here, given the head of the linked list, the task is to find the middle. For example, the middle of 1, 2, 3, 4, 5 would be 3. If there are two middle nodes, which means if the size of the linked list is even, we need to return the second middle element. So for example, the middle of 1, 2, 3, 4, 5, 6 would be 4 here. So the brute force approach, what we can think here would be to take all these elements from the linked list and push it into the array, and we'll count the size of an array and we'll return the middle element here. So instead of using array here, we can optimize a little bit by using linked list itself. We'll count the length of the linked list and we'll again calculate the middle element and we'll return that middle element. So here brute force approach takes time complexity of O of 2 cross n, where we'll iterate over the linked list two times. One would be to calculate the length of the linked list and another would be to retrieve the middle element. So let's try run this example. So here I have taken the linked list 1, 2, 3, 4, 5. We'll iterate over this linked list and find the length of the linked list. Here the length would be 5, and since 5 is an odd number, the middle element would be 5 divided by 2, which would be 2. So here the linked list element would be, since we'll take the 0 index, the second index value would be 3, so we'll return 3 in this case. So for example, our linked list size would be even, which is 1, 2, 3, 4, 5, 6. Here the length would be 6, and if we divide it by 2, the answer would be 3. So we'll take the third index value. So let me write here the indices of this linked list, and we need to retrieve the third index value here, which is the value 4. So in this case, we'll return 4 as a answer. So let's try to code this approach. So this is the code for the brute force approach we have discussed through these two examples. So here the edge case would be, if the linked list is empty, we need to return -1. So we'll handle this case in the starting step itself. So if the head node is null, we'll return -1. And step 1 would be to count the total number of nodes present in the linked list. We'll take the count variable, we'll run a loop until or unless temp becomes null. We'll increment the count value, and meanwhile we'll move the temp variable to the next pointer. So in this way we'll calculate the count, and next the second step would be to traverse again to find that middle node. So middle node will be count divided by 2. So we'll run a loop until or unless I becomes count divided by 2. We'll move the temp pointer to the next variable, and in this way we'll reach to the pointer which denotes the middle element of the linked list. So we'll return the temp's data. So let's compile and run this. So let's submit. As you can see, this problem got solved successfully. Here the time complexity would be O of 2 cross n, which is the practical time complexity, but let's try to optimize further. So let's try to optimize this approach and make time complexity in O of n both practically and overall. So here we'll take the help of two pointers, slow and fast, and we'll move these two pointers one step ahead and two step ahead. Here slow pointer would move one step ahead and fast pointer will move two step ahead, and we'll run a loop until or unless fast becomes null or fast next value becomes null. And after finishing the loop, we'll find our slow pointer at the middle position of the linked list. So in this way we'll return the slow pointer's data. And this way of solving and taking the help of two pointers is also known as tortoise hare algorithm, and it is mainly used in detecting the cycle in the linked list. So here the time complexity would be O of n and space complexity would be O of n. So let's try to code this approach. So this is the code for the optimized approach we have discussed, where we have used two pointers, fast and slow. Here if head becomes null, we'll return -1, which would be our base case, and we'll run the loop until or unless fast becomes null and fast next becomes null, and finally we'll return slow's data. So let's compile and run this code. So let's submit. So as you can see, this problem got solved successfully. Here the time complexity would be O of n and space complexity would be O of 1 as our expected time complexity and space complexity. So it was pretty straightforward question and it's asked in most companies here, so it's important as well. So this is it guys for this video. So I hope you like this video and explanation. So please give it a like, share with your friends and subscribe to my channel for more such videos. I'll see you in the next one. Thank you.